So continuing on with the nebular hypothesis, let's be very specific now about some things that we know about the solar system that we would really like a theory of where it all came from to describe for us here. So this isn't anything official, just me sort of talking here, but I have sort of 4 categories that I think the nebular hypothesis should definitely sort of satisfy. Okay, the first one is that has to sort of explain what we see right now. Okay, and so in other words, just some real obvious stuff here. We have the sun at our center of our solar system. We have all of the wonderful planets with the counterclockwise orbits. We also have the planets are all sort of rotating, and for the most part counterclockwise. I put in parentheses, but of course some are clockwise or even sort of off a bit. In this case of Venus here. And of course the planets, many of them have moons. Remember, there's something like 160 plus moons or something in the solar system. So some theory then would also have to describe that. So this is sort of the obvious thing here. What theory are you going to come up with? It says, okay, it's okay to have a glowing hot sun at the center, a bunch of planets with counterclockwise orbits. For the most part, they're also rotating counterclockwise. There are some exceptions, and also the planets can have moons on them. Okay, so next, the second category here is the planets themselves. And really, it's just that division that I discussed in the introduction to all this here. We have the small ones, or the terrestrial ones. And of course, terrestrial here always refers to being made out of rocks, like the Earth is, as you know, a terrestrial planet because we're all made out of rocks. But so are all the other inner planets. So we're talking about Mercury, Venus, Earth, and Mars. And they are small and made out of rocks. And the next thing then about the planet is that, of course, as you get past Mars, suddenly they get very large. These are, of course, not terrestrial anymore, but they're gas giants, so to speak, and they're very rich in hydrogen. In fact, there's no naturally occurring hydrogen on Earth at all. It has to be made if you want it. And, of course, the planets that we're talking about here are Jupiter, Saturn, Neptune, and Uranus. So those are the gas giants here. So the nebular hypothesis would have to describe this great variation in these great 2 divisions of the planets we see, the smaller inner ones and the large outer ones. Okay. The third category here that the nebular hypothesis better sort of attack then for us here is asteroids and comets. So of course I'll just sort of call these visitors that we see from time to time. So if you've been keeping up sort of with these videos that I've been producing here, I've even seen myself 2 or 3 comets in my lifetime that are in the sky that you sort of went out to see. And of course, you can easily do a Google search for asteroids, and there's many, many varieties and stories, and maybe one will hit the Earth someday, and all these sorts of things. And I think very early on in this class, we looked at a comet or an asteroid, I think, and sized it up relative to Los Angeles. So these things are definitely out there, and they're flying around. And so we'd really want something like an asteroid belt. And there is an asteroid belt that exists between Mars and Jupiter, sort of in that space where the planets divide themselves between the small ones. Oops, I didn't mean to erase that there. The small ones that are Mercury, Venus, Earth, and Mars. Then there's an asteroid belt, and then you get into Jupiter, Saturn, Neptune, Uranus here. So the theory would have to describe how can this asteroid belt sort of get there. And of course, then there's the Kuiper belt. And Kuiper, of course, is the name of the astronomer who first sort of proposed it was there. And I believe when he proposed it, it wasn't ever seen, but now objects in the Kuiper belt have been observed, so it is there. And of course, there's one other thing also that will describe something called the Oort cloud, which is also out there. I don't believe anything in it's ever been seen, but it's proposed to be out there. So that's sort of number 3 in my category. Okay. And then the theory also has to be a little bit flexible too. So we'll say the theory also has to have some allowances in it. Okay. So some of the allowances then that everything isn't going to be perfectly ordered in a solar system. So we'll say some of the allowances are the odd tilt of, let's say, Venus and Uranus here. So Venus is pretty much upside down. Uranus is way over on its side. So we need some allowances for that. We also need some allowances here that the Earth has a very large moon. Our moon is very large. And I guess I already mentioned this, that Venus is upside down, so we don't think it formed upside down. It was probably formed all right side up and was spinning like the other planets, but now it's upside down. And I'll just sort of put also in here things like the other tilt, like that graphic that I showed you then. Okay, so that's it. Those are my 4 categories then for whatever theory we come up with has to describe. Quick rehash for them before I end the video then. We want to explain the really obvious things that we see right now, the sun, the planets, the rotation of the moons. For the planets, we'd really like some description about how we can have 4 really small rocky planets followed by 4 very large gas giants, very different in size and structure. We'd like something to describe the visitors that we get from time to time, where the asteroids come from. There's an asteroid belt between Mars and Jupiter at the moment, and it gets into, well, there's some Kuiper belt and the Oort cloud out there, and any theory can't be totally strict. There has to be some allowances to describe some of the weird things that we see, in particular the odd tilt of Venus and Uranus here, the fact that our planet has a relatively large moon, and as I mentioned, Venus is upside down, and other tilts of the planets. So one last thing we have to describe before we get into the nebular hypothesis: what are some of the physics processes that might be involved in forming a solar system? So we'll talk about those in the next video.